Good morning, class. In the previous session, we did talk about square and square roots, and we started with the exercise 2 of this chapter. In exercise 2, we have done till question number 12, and I hope that you have already completed your work. Today, we are going to continue with the same exercise, and we are going to begin with question number 13. So you need to see the question in the book. The question says, in an auditorium, the number of rows is equal to the number of chairs in each row. That means you are going to assume the number of rows. Let the number of rows be x. Let the number of rows be x. They are saying the number of rows are equal to the number of chairs in each row. For example, we have 3 rows, 1, 2, and 3. According to them, the number of chairs in each row will be equal to the number of rows. That means if this is the first row, we have 3 chairs in it. Why 3 chairs? Because the number of rows are 3. This is just an example. Similarly, in the second row also, the number of chairs will be equal to the number of rows, that is 3. And in the third row, the number of chairs will be equal to the number of rows. Now, if you see, this arrangement of chairs in each row is actually giving us a tabular structure. We have the rows and we have the columns. So we can take the number of chairs actually as the number of columns. Is that understandable? So we can say, therefore, the number of columns or the number of chairs is also equal to x. Now, let us proceed further with the statement. They are saying, if the capacity of the auditorium is 2304, that means they have given us the total number of people who can accommodate in that particular auditorium. So total capacity is given. Total capacity is equal to, the value is 2304. Then you need to understand this diagram one more time. If I have to count the number of dots in this tabular structure, which is actually the number of chairs as far as the example goes, it will be the number of rows into the number of columns. That is 3 into 3. You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So like I said, 3 into 3 is also going to give you 9. So similarly, we are going to do this question using this concept. They want us to find the number of chairs in a row. So according to the question, I'm writing ATQ. That means according to the question, x into x should be equal to the total capacity, that is 2304. Or we can say x square is equal to 2304. We have to find the number of chairs. Number of chairs is actually the number of columns, which is also equal to the number of rows. So if I somehow find the value of x, that will be the number of chairs. So what we have to do in this question is, we have to find the square root of 2304. This is what we have to do in this question. So from here, we are going to begin solving this particular question. So let's do it. What we have to do, we have to find the square root of 2304 in order to calculate the value of x. So let us do it. So finding the square root of 2304, you can do it by any method, either by prime factorization or the long division. I'm going to do it by long division. So we have 2304 and I will go for long division. I believe you remember the steps. We are going to make pairs out of this number. So pairing starts from right to left. So the first pair and the second pair. Our focus is on 23. A digit which when multiplied gives me this or less than this. So 6 into 6 is 36, 5 into 5 is 25, We cannot take them both. So our option will be 4 into 4. So this is 4 into 4, that is going to give you 16. 13 minus 6 is 7. That's it. And we are going to take down the next pair. What will happen to this quotient? It will be added. So the divisor becomes 4 plus 4, that is 8. Now we are going to put a digit after 8 such that when it is multiplied to the resultant number, it should give me this or less than this. So let us try putting 8 after it. Why I am doing it? Because I know that the last digit is 4, which will be possible if the last digit is either 2, because 2 into 2 is 4, or it is 8 into 8, that is also giving me 4 as the last digit, that is 64. So let us try putting 8 towards the end. So if I put 8 towards the end of this number, I have to multiply this resultant number by 8. 8 into 8 is 64. 8 into 8 is 64 plus 6 is 70. So I get exactly the same number. So therefore I am going to put 8 here. I'll multiply it by 8 and the resultant will be 704. So the square root that I obtained is 48. So hence the value of x is equal to 48, and that will become my answer. Why so? Because they wanted me to find the total number of chairs in each row. The number of chairs in each row was equal to the number of rows. I have assumed it to be x, and therefore the value of x when it comes 48, there are 48 chairs in auditorium. I hope this part is clear. Now if you see question number 14, it is exactly the same. The total number of plants is given, and they are saying that there are as many rows as there are plants. So it will be done in the same manner. You have to understand that you are going to assume the number of plants in each row to be x, and then the number of rows is also x. So at the end, x into x will give you the total number of plants which is given in the question. So question number 14 is exactly the same. It will be your homework and you are going to do it in the same manner. I am going to proceed with question number 15 now. So let's do question number 15. So kindly see the question in the book. We are proceeding further with question number 15. Okay, question number 15 says, an army officer wishes to arrange 4770 soldiers. So the total soldiers are given. So let us write the given statement. Total soldiers which are given in the question are 4770. 4770 soldiers in the form of a square. So these soldiers are arranged by the officer in the form of a square. Now what is a square? Square is something which has all the sides equal. That means it is a figure in which all the sides are equal. Now sides we cannot speak because the soldiers are standing. This will be equal to this and this will be equal to this. So I am going to treat it in the same manner. The number of rows should be equal to the number of columns if you want the square to be built. So the number of rows will be equal to the number of columns. This is how the officer is trying to arrange the soldiers. Now they are saying after arranging, he finds that 9 soldiers are left out. Find the number of soldiers in each row. That means once he has arranged all the soldiers in the form of a square, 9 soldiers were still left out. So the number of soldiers who are actually standing in the arrangement. Soldiers standing as per the arrangement. Which arrangement am I talking about? I am talking about the arrangement in the form of square. How many of them are there? They are in total 4770 minus 9, because 9 of the soldiers are left out. So how many soldiers are there? Exactly So we are going to subtract 9 from 4770. So let us subtract it. 4770 minus 9. So let's do it in the rough column. 10 minus 9 is 1. It is 6, then 7 and 4. That means he has already arranged how many soldiers in the form of the square? He has arranged 4, 7, 6, 1. These soldiers are standing according to the arrangement. The arrangement is in the form of a square. Now they are saying find the number of soldiers in each row. Now in each row we are going to understand that it has to be the square term. So we are going to find the square root of it. Therefore, number of soldiers in each row will be given by, if you relate it to the previous question that I have told you, the square root of 4761. So in this question, again we are going to proceed further to find the square root of 4761. So let us do it. 4761, and I am going to do it by the long division method again. Pairing it, going for the long division part. 4761. So 9 9s are 81, 6 6 are 36, 7 7s are 49. So I am going to go with 6 into 6 is going to give me 36. Subtraction happens. 7 minus 6 is 1, 4 minus 3 is 1. The next pair comes down. This quotient is added to the divisor and we get 12. We have to put something towards the end of 12, a digit, such that when it is multiplied to the complete number, it should give me this. Now 1 you will obtain only when 1 is multiplied to 1 or 9 is multiplied to 9. 9 into 9 is 81. That means the last digit will be 1. So let us put 9 towards the end of 12. If I do it, let's see what is the answer. So 129 into 9, 9 9s are 81, 9 2s are 18 plus 8 is 26, 9 1s are 9 plus 2 is 11. So we are getting the same thing. So hence I am going to put 9 here into 9 will give me 1161. So therefore the number of soldiers in each row is equal to 69 soldiers, and that will be my answer. 69 soldiers in total. So this is how we are going to do it. So in this question they said there are certain soldiers and the army officer was trying to arrange them in the form of square. He did it, but then 9 of the soldiers were left. When 9 of the soldiers were left, so I found how many of them were actually there. And how did I find it? By subtracting 9 from the total number of soldiers. So actually 4761 soldiers are standing according to the arrangement, that is in the form of square. So the number of soldiers in each row will be given by the square root of 4761. And when I found it, it came equal to 69. So 69 soldiers are standing in each row, and that becomes our answer. Fine. After this, we move on with question number 16. We proceed further with question number 16. And in this question, they are asking us to find the least number that must be subtracted from each of the following numbers to get a perfect square. Also find the square root of the perfect square. Now, this type of question we have already done. It was in question number, let me see it. It was in question number 9, wherein we were finding the number to be increased, decreased, multiplied or divided from the given number to actually make it a perfect square. So in this they are concentrating on to the subtraction part. So I'm going to do one specific part of this question, so I'm going to do the third part of it. So as the homework, you are going to do the first part of question number 16. I'm doing the third part. So in the third part, the number given is 786. Given number is 786, and we need to find the required number which has to be subtracted. I told you earlier that whenever we have to find a number to be added or subtracted, we are going to go with the long division method. So let us start with the long division of 786 to find the square root. Okay, though 786 is not a perfect square, we are finding a perfect square by finding a particular number which can be subtracted from it to actually turn it into a perfect square. The first thing first, the pairing is done from right to left. So 7 is left alone. 2 into 2 is 4, 3 into 3 is 9. So I am going to go with 2. 2 into 2 is 4. Subtraction happens. 7 minus 4 is 3 and the pair is taken down. This quotient will be added to the current divisor. 2 plus 2 is 4. So I am going to put a number, a digit after 4 so that when it is multiplied to the resultant number, it gives me either this or less than this. So I have 38 here. So I know 9 4s are 36. But then 9 9s is 81. So it will be way beyond. So let us try it with hit and trial method. This says that we are going to guess the values and we are going to do it. So let us keep 5 towards the end of 4 and see what happens. Into 5 is going to give me 5 5s are 25. 5 4s are 20 plus 2 is 22. So it is less than the number. Let us put 6. This is a rough column. See to it that you make proper rough columns. Let us put 6 towards the end of 4 and see what happens. 6 6 are 36. 6 4s are 24 plus 3 is 27. It is still less than 386. I'm going to put 7 now. 47 into 7. So 7 7s are 49. 7 4s are 28 plus 4 is 32. So it is still less. So let us try it by 48. So 48 into 8. 8 8s are 64. 8 4s are 32 plus 6 is 38. So 384 is very near to it. I'm going to go with 8. So I'm going to put 8 after 4 and I'm going to multiply it by 8 to get the value as 384. Subtraction happens and the result is 2. So I have told you earlier, whenever we are finding a number to be subtracted, it is equal to the remainder. So we are going to write therefore the required number to be subtracted is equal to the remainder. The remainder of long division. And what is the value of the remainder? The remainder is 2. So 2 is the answer, one of the answer that they are asking for. Now they also want to know the perfect square. They have said that not only you have to find the required number, you also have to find the square root of the perfect square. So before we find the square root of the perfect square, we are going to find the number. So the number, the perfect square, resultant perfect square will be the original number given, that is 786 minus 2. So actually the perfect square number is 784. And what will be the square root of it? It is very clear, in the long division we have already obtained it. It will be 28. Therefore, the square root of 784, which we have already done, will be equal to 28 plus minus. So that should be the second answer they are asking for. So in this question we have found that what the number has to be subtracted from the given number to turn it into a perfect square, and we have also found the square root of the resultant perfect square. This is how we have to do it. So the first part of this question will become your homework. Now I am going to proceed further with question number 17. And again I am going to do the third part of it, and you are going to attempt the first part as your homework. Question number 17 says, find the least number which must be added to each of the following numbers to make it perfect square, and we have to find the square root of the perfect square. The third part is given as 4725. So the given number is 4725. Again, like I said, whenever we have to find a number to be added or subtracted, we are going to go with the long division method. So let us quickly go with the long division method. The pairing starts, the first pair, the second pair, moving on to the long division thing. 6 6 is 36, 7 7 is 49, so I am going to go with 6. 6 into 6 is 36. 7 minus 6 is 1, 4 minus 3 is 1. The next two digits come down as a pair. This quotient is added to the current divisor. It becomes 12. And now we are going to put a digit after 12 to make it somehow equal to this or less than this. So let us try it out in the rough column. So in the rough column, we are going to find the digit to be placed. Okay. So if I am going to put 8, for example. So into 8 will be done. 8 8 is 64. 8 2 is 16 plus 6 is 22. 8 1 is 8 plus 2 is 10, which seems to be less than this. Let us put 9 at the end. Remember, we cannot go beyond 9. The digits which can be placed towards the end of the current divisor are actually from 0 to 9. Digit means a single digit. 9 into 9 is 81. 9 2 is 18 plus 8 is 26. 9 1 is 9 plus 2 is 11. So we have 1161, which is more than 1125. That means I am going to go with 8. So let us do it. I'm going to put 8 towards the end of this. It will be multiplied to 8 and it is 1024. Subtraction happens. 5 minus 4 is 1. 2 minus 2 is 0. 1 minus 0 is 1. So 101 is the remainder. Now in the case of finding the required number to be added, I have already given you the formula in question number 9. I'm again going to repeat it. So let me tell you what has to be done. The required number to be added is given by q plus 1 whole square. Now what is this q here? It is the quotient that you have obtained in the long division minus the given number. You have to subtract the given number from q plus 1 whole square. Now what is this q? Q is the quotient that you have obtained. So that means the answer you will obtain by finding the square of 68 plus 1, that is 69, minus the given number, that is 4725. So let us quickly find the square of 69. 69 into 69. 9 9s are 81. 9 6s are 54 plus 8 is 62. 6 9s are 54. 6 6s are 36 plus 5 is 41. So it is 1. 2 plus 4 is 6. 6 plus 1 is 7. 4. 4 7 6 1. So the square of 69 comes equal to 4761, and we are going to subtract 4725 from it. So subtracting 4725 from the square of 69, so we are going to subtract 4725 because it is the given number in this particular question. 11 minus 5 is 6. 5 minus 2 is 3. So actually the number to be added in this particular question will be equal to 36, and that is going to be our answer. So let us keep it very short and simple. Whenever we have to find the number to be subtracted, we are going to go with long division and the remainder will be the answer. And whenever we have to find the number to be added, we are again going to go for the long division, and the required number will be equal to q plus 1 whole square minus given number. So our answer in this question is 36. Okay, let us proceed further with question number 18, which says that we have to find the greatest 6-digit number which is a perfect square. Now when we talk about a greatest number, that will be in the sequence of 9. So let us first write the greatest number, which is having how many digits in it? 6 digits. So a greatest 6-digit number. The greatest 6-digit number will be all in the sequence of 9, because 9 is the largest single digit. So it will be 9999999. So if we have 6 nines in a sequence, that is the greatest 6-digit number. But according to the question, we have to find the 6-digit number which has to be greatest, but at the same time it should be a perfect square. For that, we are going to continue with the long division method. Why I am emphasizing more on long division? Because either the number will be added or subtracted from this assumed number in order to turn out it into a perfect square. So let us start with the long division of this greatest 6-digit number that we have taken. We are going to write the given number in the form of pairs. There are 6 nines, so pairing them from right to left and starting with the long division method. 9 into 9 is 81. Like I have already told you that we can select only the digits from 0 to 9, because digit means a single digit. We cannot take a 2-digit number or more than that. So the best possible option that we have is 9. So 9 into 9 is 81. The subtraction occurs. 9 minus 1 is 8 and 9 minus 8 is 1. We are going to take down the next pair. What will happen to this quotient? It will be added to the current divisor. 9 plus 9 is 18. We are going to put a digit after this such that we get this number or a number less than this. So let us work in the rough column now. We are going to put a digit after 18. So let us try it with 9. 9 into 9 is 81. 9 into 8 is 72. 72 plus 8 is 80. 9 was the 9. 9 plus 8 is 17. So it is 1701. So that is the best possible option. Like I said, we cannot go beyond the digit 9. So I am going to continue by putting 9 towards the end of 18 and multiplying it by 9. The result is 1701. Subtraction occurs again. 9 minus 1 is 8. 9 minus 0 is 9. 8 minus 7 is 1. We are going to take down the next pair. What will happen to the quotient? The current quotient will be added to the divisor. 9 plus 9 is 18. 8 plus 1 is 9 and 1. So we have 198. So again we have to put a digit after it. So I'm going to put a 9 after this. And I'm going to multiply this resultant number with 9. 9 9s are 81. 9 8s are 72 plus 8 is 80. 9 9s are 81. 81 plus 8 is 89. 9 was a 9. 9 plus 8 is 17. So we get 1989 into 9, which is going to give me 17901. We are going to subtract it. 9 minus 1 is 8. 9 minus 0 is 9. 8 minus 9 is not possible. So 18 minus 9 is 9. 8 minus 7 is 1. So the remainder is 1998. So the quotient in the long division happens to be 999. And the remainder in this particular long division is equal to 1998. Now I need you to focus on the assumed number, that is the greatest number that is possible of 6 digit. If we are going to add even 1 to it, it is not going to be 6 digit anymore. It will become 7 digit. So in this type of question, when we are finding the greatest number, we are going to go for subtraction. So we have to find the required number which must be subtracted from this assumed number to actually get the answer. So that's why the required number to be subtracted. We have already seen it in the previous few questions. It will be the remainder obtained in this question. What is the remainder obtained? The remainder obtained in this question is 1998. So therefore the resultant perfect square, which is actually a 6-digit number, will be given by the subtraction. That means the given number, which was 999, that means a 6-digit number, minus the remainder, that is 1998. Let us perform this subtraction in the rough column. We have 1, 2, 3, 4, 5, 6 nines, and we are going to subtract 1998 from it. Let us do it. 9 minus 8 is 1. This is 0, this is 0, and 9 minus 1 is 8. Then what do we have? We have 9 and 9. So the resultant number, which is a perfect square and it is a 6-digit number also, is 998001. So hence, the greatest 6-digit perfect square is actually equal to the number that we have calculated, 998001, and that becomes our final answer. This is how we are going to do it. In question number 19 now, we are going to find the smallest 6-digit number, which has to be a perfect square. So like in the case of greatest number, we take the sequence of 9. In the case of smallest number, we are going to take the sequence with 1 in the starting and the rest of the digits will be 0. So we are going to write the possible smallest 6-digit number first. So the smallest 6-digit number, if we write, it will be equal to 1 followed by how many zeros in it? 5 zeros. So that in total it becomes 1, 2, 3, 4, 5, 6. So 6 digits are there now. So again, because we have to find a number to be added or subtracted in these type of questions, we are going to proceed further with long division. So writing the number, making the pairs from right to left, and starting with the long division. It is 10. So we are going to begin with 3. 3 into 3 is 9. Subtraction, 10 minus 9 is 1. The pair comes down. Quotient is added to the divisor. 3 plus 3 is 6. We have to put a digit in such a way that once we multiply it to the resultant number, it should give me the number, that is 100. So let us try it with 2. Into 2 will give me 124, which will be more than the number here. It is 100. So the only option that I have is 1. So 61 into 1 is going to give me 61. Subtraction occurs. 10 minus 1 is 9. 9 is left. 9 minus 6 is 3. And the next pair comes down. What happens to the current quotient? It is added. So we have 62 as a new divisor. I am going to put a digit after 62 to actually try to get 3900 or less than this. I know 6 into 6 is 36, so let us try putting 6 at the end. So into 6, 6 6 is 36, 6 2 is 12, plus 3 is 15, 6 6 is 36, plus 1 is 37. So 3756. Let us try it out with 7 also. 627 into 7. So 7 into 7 is 49. 7 2 is 14, plus 4 is 18. 7 6 is 42, plus 1 is 43, which will be more than 3900. So the only option I have is by putting 6 towards the end of this current divisor. So putting 6 and multiplying it by 6, the number that I obtained is 3756. the subtraction occurs. 10 minus 6 is 4, 9 minus 5 is 4, 8 minus 7 is 1. I'm not going to go beyond that. Now understand that if we are going to subtract something from it, it is going to give me a 5-digit number. So in the questions where we have to find the smallest number, instead of subtraction, we are going to go for addition. So we have to find the required number that has to be added to make it a perfect square. So required number to be added this time will be equal to, I believe you remember the formula that I have given you in the previous question. It will be equal to q plus 1 whole square minus given number, where q is the current quotient. So it will be 316 plus 1. 316 is the quotient. So 316 plus 1 is 317. So 317 whole square minus the given number, that is the current number, that is 100000. That is the assumed 6-digit number. So finding the square of 317 now. So let us find it quickly. 317 into 317. 7 into 7 is 49. 7 1 is 7 plus 4 is 11. 7 3 is 21 plus 1 is 22. 317. 3 7 is 21. 3 1 is 3 plus 2 is 5. 3 3 is 9. So it is 9. 7 plus 1 is 8. 3 plus 1 4. 5 plus 5 10. And this is also 10. So we get 100489. So the square of 317 comes equal to 100489. And what will be subtracted from it? It will be the current assumed number. So 100000 will be subtracted. So the difference would be 489. So this number has to be added to the current number to actually make it a perfect square. Or simply you can say q plus 1 whole square is going to give you the answer. So here the greatest, not the greatest, but the smallest 6-digit number, directly also it can be done, which is a perfect square, is given by q plus 1 whole square, that is equal to 100489. That should be our final answer. Either you add 489 to the given number, which is again going to give you this only. So instead of finding this, you better write it as that the smallest 6-digit number, which is a perfect square, will be given by the current quotient plus 1 whole square. So 100489 will be our final answer.